Unit 10, Part 5. Okay, we've introduced you to the basic motivation for this new kind of logic and given a bit of an overview of where we're going, how we can grasp the validity of arguments like the one we had up before. If all Australians are surfers, Dan is Australian, therefore Dan is a surfer. So now let me give you a few translations, how we go about symbolizing various sentences in this new logic. So we've seen Dan is Australian, right? Think of it as the combination of the propositional function, right, which is AX, but we're replacing the X with the individual variable, D. Okay, so what I want you to grasp here is what combinations are allowed, which combinations are not allowed. How do I write, well, let's make it August, because August is watching me, not Eden. August is not Australian. August is not Australian. A-U-G-U-S-T. August is not Australian. How do we symbolize that? Notice what we don't do, okay? I'll give you a few wrong answers. You don't write anything like this. Okay, so I'm going to use a lowercase a as the individual constant referring to August. Okay, you don't do this. This is wrong, right? You do not put the negation here, right? Propositional functions, the combination is always the propositional function and the individual variable there. That's the singular sentence, right? August is Australian. We have to grasp August is not Australian, right? What logical structure does it have? It's August is Australian, negated, right? It's the negation of that. So we take August is Australian as basic and we negate it. That's where the negation sign goes, okay? So it's important to grasp here what strings of symbols are formulas and which ones are not, right? Which combinations of symbols are legal formulas, which ones are not. The one that I crossed out, capital uppercase A, negation A, no, not legal. You can't have any negations down here, right? What this is August is Australian. It is not the case that August is Australian. That's our symbolization for this. August is not Australian. That is equivalent to, right, August is not Australian is equivalent to, it is not the case that blank, August is Australian. Okay, so we're negating that sentence. All right, 1 and 2, so how would I symbolize Dan is Australian and August is not Australian? Okay, ask yourself as always, what's the major operator, right? The major operator is and, right? It's the conjunction. It's a sentence on the left, a sentence on the right, right? These are both sentences. These are both going to be complete formulas, as these both are. Right? That is a complete singular sentence. That is also a complete singular sentence. This is officially got some complexity to it, right? It's got a negation sign. 1 and 2, right? It's just the major operator is going to be the dot, right? And I've got AD on the left and not AA on the right. Okay? That's how you do that, right? It's a combination. So you got to get used to start thinking this in terms of logical forms and what constructions are legal, which ones are not, right? That's a sentence. That's a complete legal thing. Very important to always be cognizant of what's complete, what's not complete. AX, or even not AX, those are both incomplete because they have variables that are unbound. Right? They have variables that they have not been replaced by individual constants, so they haven't made singular sentences. One way of making formulas from propositional functions which are incomplete. The other way to make sentences with propositional functions, or the other way to make sentences, complete things capable of true or false, from propositional functions which are incomplete, not true or false, is to annex quantifiers, and doing that is we call binding the variable. The quantifier binds the variable. It's kind of like the scope of a negation, right? So when we say got a propositional function AX, X is Australian, universal quantifier for all X, X is Australian, that binds the quantifier X. and it completes that sentence. Now you are, so just notice that it's true. You know this is true, just realize that it's true, that when I say X is Australian, you can see that I have not said anything true or false. But if I tell you for all X, X is Australian, everything is Australian, now I have said something which you can evaluate as true or false. All things Australian, unfortunately, is false. But there exists an X such that X is Australian, binding the variable X with the existential quantifier. There exists an X, X is Australian, that is a quantifier statement which is true. That's a quantifier statement which is true, right? There exists an X such that X is Australian, I have said something true. Whereas just saying AX, just saying X is Australian, not true or false. Okay, so that's important because you have to be very much aware of what's complete and what's incomplete. All right, so let's do this one. You'll see more of this in later chapters, but here's the sentence. If all Australians are surfers, then Dan is Australian. All right, so what's the major operator here? What's going to be the overall form of the thing? The overall form of this thing is going to be if then, right? It's going to be a hook. So this is going to be a conditional. So its major operator is going to be a hook, right? And there will be a sentence to the left and a sentence to the right. That's different from if the sentence was just all Australians are surfers. We saw in our translation of our initial argument, right? All Australians are surfers, Dan is Australian, therefore Dan is a surfer. We saw there how to translate all Australians are surfers, right? That is not a conditional. All Australians are surfers is a universal statement rather than a conditional. And I want you to be very clear on the either or. A statement is either a quantifier statement, right? Or it is a conditional or a negation or a conjunction or a disjunction. If it's one of those things, it cannot be the other. Think of those as exclusive categories. Quantifier statement or conjunction, disjunction, right? A quantifier statement or one of the options for the truth functional combinations. It's, if it is a conjunction, it's not a quantifier statement. If it's a disjunction, if it's a conditional, it is not a quantifier statement. And similarly, if it is a quantifier statement, it is not a conditional or a conjunction. Okay, so this is going to be a conditional. The major operator is if then. And what is the antecedent of this conditional? Okay, it's the sentence, all surfers are Australian. So we have a quantifier statement as the antecedent of a conditional. This will be a very important possibility for how to make sentences, especially in Unit 15, which is the big one, because that's where you do proofs, and most of the actual assessment is actually doing proofs. Okay, so the translation of that we saw was, for all X, if X is Australian, then X is a surfer, right? For all X, if X is Australian, then X is a surfer, that's a hook, all right? This will be very important for Unit 14, we'll teach you this many times, but, okay, so let me complete it first. Okay, that's my antecedent, a consequent, then Dan is Australian. What's the consequent then? It is Dan is Australian, we saw that in number 1, A, D, right? Well, that's weird. You've got a quantifier, you've got a conditional, the major operator is a conditional. On the left-hand side, the antecedent of the conditional is a quantifier statement. It has a quantifier, it quantifies over some propositional function, but the consequent has no quantifiers. It's rather a singular sentence. That's legal, that's fine. The rules for constructing truth functional combinations or truth functional formulas, right? The rules for constructing conditionals is